Hi, I'm Iain and welcome back to the Northland workshop. This is an impact driver. This is a radial arm saw, that's a radial arm saw, and that's a radial arm saw. What is different about the impact driver and these three radial arm saws? Well, nowadays, if I want to choose an impact driver such as this one, I could simply go online and I'll find hundreds of different reviews and tool tests and talking heads telling me how this impact driver compares to, say, DeWalt's impact driver or Bosch's or Makita's, whoever's impact driver. There are just tons of tool reviews and tool comparisons for things such as this. However, I've yet to find a good comparison, or really any comparison at all, of old radial arm saws. And yet people are still buying old radial arm saws, and most people want to know, how does this compare to that, Well, unfortunately, I can't do that in this video because there's just too many radial arm saws out there. I have 3, but there are hundreds of models out there to choose from. The other thing is that really, comparisons like that fall apart because it really comes down to personal preference. What works best for you for a radial arm saw might not be the best radial arm saw for me. What is the best radial arm saw for me might not be the best radial arm saw for how you would use it. So in this video, instead of trying to compare one to another, I thought I would go over some of the features of radial arm saws, so that way you can get an idea of what's available out there for features, and you can come to a conclusion of which saw is right for you. Here are the 3 saws we're going to be talking about today. We've got a large saw, a medium saw, and a small saw. And these represent typically the range of sizes or classes of saw that you're going to come up against in the wild. Let's start with arbor size, because this is one of those things that you don't think about until after you buy the saw and you're ready to buy a saw blade or accessories for it. Once you hit 12-inch diameter blades and above, typically they're going to want a 1-inch diameter arbor. If we take a look at this saw that takes a 14-inch diameter blade, you will see that it has a 1-inch diameter arbor. That's fine, there's nothing wrong with that. It's a very strong arbor, which it needs for bigger accessories. The downside, however, is that the accessories that come with a 1-inch diameter hole are more limited than, say, a 5/8 inch arbor hole, and they tend to be more expensive because they're a bigger accessory. If there's an upside to that, it's that anything that's coming with a 1-inch diameter arbor hole, it's designed for heavy industrial use. So chances are it is going to do everything you can possibly want of it in a small shop. Here we are at the medium and the small saw. And if we take a look at these, we're going to realize that they share something in common. That is that they have a 5/8 diameter arbor. This is a typical arbor size that you're going to find on lots of smaller shop equipment. The nice thing about that is because it's so common, the dado heads, the molding head cutters, stuff like that are plentiful and relatively inexpensive. So the cost for the accessories to run a 5/8 arbor is going to be way cheaper than the cost for the accessories to put on a 1-inch arbor. There's another benefit to a 5/8 arbor. That is that these radial arm saws were made for smaller shops, and particularly the ones that were made for home shops had lots of interesting accessories for them, such as the jigsaw attachment. Now, this jigsaw attachment is designed to fit on a 5/8 arbor. You're not going to find a jigsaw attachment to fit on a 1-inch arbor saw. The reason for that is once you hit a 1-inch diameter arbor, you're dealing with an industrial saw that was originally designed for heavy industry. The idea being that that radial arm saw was only going to do radial arm saw things. It doesn't make any sense for a cabinet shop to pull the blade off the radial arm saw to put on a jigsaw attachment. If they need to cut curves in a cabinet shop, they're going to have a dedicated bandsaw to do that. Same thing with a disc sander. You can get disc sander attachments that fit on 5/8 diameter arbors. They are almost non-existent for 1-inch diameter arbors unless you have them made. The reason for that is if a cabinet shop needs a disc sander, they're going to go out and buy a disc sander because time is money and they don't have time to switch it back and forth from a disc sander to a radial arm saw. So if you're trying to get the most versatility in accessories, probably going to want to think about a 5/8 diameter arbor. Speaking of 5/8 diameter arbors, here we have one of the smallest radial arm saws you can get with a 5/8 diameter arbor. What that means is that you could get typical home shop accessories like a jigsaw attachment or say a disc sander and fit it to this saw, and it might be tempting to try and fit a 10-inch diameter blade on this saw, but it won't work. The reason for that is the blade guard. You want to check the saw that you're about to purchase and find out what is the biggest diameter blade you can fit on that saw. In this case, this one can take a 10-inch diameter blade. The guard is sized for that, and the motor has enough power to run that. This one, on the other hand, has a blade guard that is sized to take a 9-inch diameter blade max, but it has a 0.5 horsepower. So it would struggle a little bit trying to run a 9-inch blade in hardwood. The nice thing is, nobody says you have to run the max diameter blade in your saw at all times. That's why I have an 8-inch blade in this saw, and the 0.5 horsepower likes it much better. But if I needed full depth of cut, I could go up to a 9-inch diameter blade. But if you have your heart set on a 10-inch diameter blade, you want to make sure when you're purchasing a saw that it can actually take a 10-inch diameter blade. Speaking of small saws, this little saw, even though it has a smaller than usual blade on it, as in the 8-inch blade versus a 9-inch blade, it can still cut through a 2x4 laying down in one pass. And that is really plenty for making furniture. If you have to cut a 4x4 for some reason, you can simply cut through half of it, flip it over, and cut through the other half. Again, we're not making post and beam buildings here, we're making furniture. Your radial arm saw that you're looking to buy is probably somewhere in the range of a 0.5 horsepower all the way up to even 10 horsepower. Sometimes even more than that, but those are really big specialty saws. The common ones you're going to find are 0.5 horsepower, 3/4, 1, 1.5, 3, 7.5, and maybe 10. Really, any of them are going to work for hobby shop type stuff. You're not in a production environment, you're not trying to feed the wood through the saw as fast as possible. If you have to slow down a little bit to let the saw work, so be it. However, if you're trying to use as many accessories as you can possibly get for your saw, you're probably going to want to stay with a minimum of about 3/4 of a horsepower. There are a lot of 0.5 horsepower saws out there. They do a good job, but if you get a good deal on a 3/4 or above horsepower saw, probably the way to go. Just be aware, 1.5 horsepower is probably the most you're going to be able to run on 120 volts. Once you hit 2 and above, you're looking at 240. Let's face it, if you're spending money on a saw, or even if you're getting it for free, it's a bit of work to move a radial arm saw into a shop, so you want to make sure it's worth your while. And by that, I mean build quality. And one of the easiest ways to tell build quality of a saw is the arm. Now, All the manufacturers of saws have had some good models, and they've had some really, really junky models over the years. But one easy way to get a good idea of the overall build quality of the saw is the quality of the arm. On the older saws, especially the older, better saws, it's a bare cast iron arm. As you can see, this is cast iron, cast iron, cast iron. As far as I know, all radial arm saws have cast iron in the arm somewhere, but somewhere in the late 60s, early 70s, they started covering up the cast iron with either aluminum sheeting or later on plastic over it. And that was to kind of disguise the fact that there was less and less cast iron actually in there. If you can't see cast iron looking at the arm, if it's covered by plastic or aluminum sheet metal or something like that, it doesn't necessarily mean it's a bad saw. It just means you probably want to look up under it to make sure that it still has a solid cast iron arm and it doesn't have lots of big holes in it where they were trying to reduce the weight. The issue with that is by the time they got around to trying to cover up the cast iron arm, they were trying to shave weight off the thing, and therefore the rigidity of the saw suffers. You've got a lot of weight cantilevered quite a big distance on this thing. You want a rigid arm to be able to support that. So, assuming that you've looked at the arm and you're satisfied with the amount of cast iron that's in it, there's some other arm features you might want to look at underneath. Over the years, there have been many different techniques to get the carriage and the carriage bearings to ride back and forth in the arm. Sometimes the bearings are in the arm, on other models they're outside the arm, but we're going to look at the three most common internal rail systems. In this case, this one has hardened steel bars that the bearings ride on. And if after years and years of cutting, molding, so it only moves a little bit again and again, if it wears out these rods right here, you can simply loosen up the bolts that hold them on and rotate the rods to a fresh spot, or if they wear out entirely, you just replace them with new hardened steel guide rods. That's a feature that you're likely to see on an industrial saw where they're planning on a lumberyard worker making thousands and thousands of cuts in 2x4s over the same 3.5 inches for years and years. Probably the most common way of letting the bearings roll back and forth in the arm is to simply mill out a half-round groove in it. And that is perfectly acceptable. The only time you might want to be a little cautious of something like this is if this saw came out of a sawmill or a lumberyard where it spent years and years and years cross-cutting 2x4s. The part closest to the post might be worn out, but you can tell that fairly quickly just sliding it back and forth. If it clunks as it moves back and forth, you might want to investigate further. I wouldn't rule the saw out completely at this point because it could be that there's just years of sawdust and gunk packed in here that might be able to be cleaned out and the thing works perfectly, but it's just something to be aware of. If it has milled grooves in this and the grooves are worn, you either have to have a machine shop mill the grooves again, or you're looking for a replacement arm. Here's one more style. This uses hardened steel guide rails that are half round, but instead of being concave and milled into the cast iron arm, these are convex and they stick out. So it takes a different type of bearing that's kind of hidden behind these little felt wipers here that keep sawdust cleaned off. The nice thing about these is if it wears close to the post, you can always take these rails out and flip them 180 degrees and you get a new section closer to the post. But again, unless this came out of a lumber yard, chances are the saw is not going to have any appreciable wear in the arm. On the topic of arms, there's really two different styles of arms that you're going to run into out in the wild. There is the turret style, which is named after the fact that this kind of looks like a turret on a battleship right here. And there's the single arm, which is like the two DeWalt's back there. There are fans of both styles, and whichever one you get, really, as long as it's a high quality saw, you'll be happy with it. If you're wondering what the difference is and why some of them have this turret style, it is for the fact that with these single arm saws, as we will demonstrate in a minute, it's pretty much impossible to miter to the left without concocting some sort of jig or fixture that goes on there and allows you to do that. Here, with the turret, you can actually make use of the entire crosscut capacity on the table in the left-hand mode. So if I raise this up so it clears the table, and I pull the saw forward, if I unlock this and I pull the miter detent and make sure I don't slam it into the fence, I can go to 45 degrees. And if we look with it all the way extended out, that saw blade is still over the table. If I was to push the fence back, I could get the regular crosscut capacity in the left-hand miter. If I try the same maneuver with this saw, I crank it up so the blade's not down in the curve, pull it forward, I can unlock it and swing it to 45 degrees. And it ran into the light and the fence, like so. You can see because of the way the blade is, it's not on the table at all. There's no way to make a left-hand miter with this thing. Depending on what publications you have for radial arm saw operation, there was a book by DeWalt back in the 50s that recommended simply turning the blade around like this, grabbing it from the back, and using it like this to make left-hand miters. There's a lot wrong with this way of doing it. First of all, yes, they do say you have to rotate this guard down so it just barely clears the wood, because the rotation of the blade means it's going to be throwing lots of sawdust back at your face. By rotating it like this, kind of like a rip cut, it will catch the sawdust and it'll come out here. Okay, fine, that fixed that. The bigger issue is that this defeats half of the operation of the radial arm saw, in that normally, the normal rotation of the blade for cross-cutting or mitering, it pushes the workpiece down to the table and back towards the fence. Here, it's doing the opposite of that. You're cutting on the pull stroke, so the blade here is trying to lift the workpiece off the table and throw it at you. So, no, that's a stupid idea, and yes, technically you could do it that way and keep it on the table and use the 45 degree stop in this direction, but I don't know anybody who actually does it like this. Now, I'm in no way trying to give you the impression that a single arm saw is not a good radial arm saw. It is a perfectly good radial arm saw if it's a quality saw. And there are jigs that you can build to get around the whole left-hand miter thing. So don't think of that as a deal breaker. If you find a single arm saw that you really like and it's a high quality saw, by all means, get it. It will do everything you want. You're just going to have to make a jig for it. Likewise, not every double arm saw out there is a good saw or one that you're going to want in your shop. If it's a high quality one, yes. If it's a low quality one, regardless of arm design, it's probably something you want to stay away from. Since we're on the subject of mitering things, let's take a look at miter detents. If we take a look at this DeWalt, you can see that it has notches cut into the top of the arm at 90 and 45 degrees in this direction, and because they had a weird sense of humor back then, 45 degrees in the other direction. Nobody uses the 45 degrees in the other direction, as we just discussed. But in the 90 and the 45 degrees, it is used quite a bit. If you need to make an adjustment to get the blade 90 degrees to the fence, you can loosen up these two set screws, and there's two screws here that shove the actual locking pin back and forth that changes the angle of the arm ever so slightly. This pin is wedge shaped, so that way even as these detents start to wear, it always wedges down into the center of it and it takes up the slop automatically. If there's a downside to this setup in how it adjusts for 90 degrees, it's that there's no separate adjustment between 90 degrees and 45. You adjust this thing for one of them, you're adjusting it for both of them, and you're counting on DeWalt milling these slots at an accurate angle. The good news is, at least on these old ones, they did a superb job milling them at accurate angles. But if they weren't so good, there's nothing you can do about it. You would just have to choose one over the other and deal with it. However, some saws allow you to independently adjust the detent for 45 to the right, 90, and 45 to the left. The nice thing about this is you can really fine-tune all the angles. The downside is when you do set up your saw for the first time, you're going to have to take this little cover off, if it's this particular model, and fiddle around down in there to get them set. The good news is, no matter which saw you get, if it's a high quality saw, once you get these detents set, unless you back into them with a car, they should be good to go for a very, very long time. For that little mitering demonstration, I just had to raise up all three saws, so now's a good time to talk about different ways of raising and lowering radial arm saws. There are three basic locations for the height adjustment crank on radial arm saws. There's the front mounted crank that is right in front of the table, and you simply crank it and it adjusts the saw up and down. If there's a benefit to this, it's that you don't have to reach all the way into the back of a larger saw, and you get a bit more power cranking at this level than reaching way back on top of the column. If there's a downside to it, it's that you've got a set of bevel gears in here and some bronze bushings to take the drive shaft that's going back and turn it 90 degrees to the threaded rod going up and down in the post. You can also see that there's some backlash in this. That's really not slop in the column, that's just backlash in the gear train here. So the column doesn't slop up and down like that. This is just from the edge of one gear tooth when I go the other way to the edge of the other gear tooth, if you're wondering what that is. Probably the most common height adjustment for a radial arm saw is a simple crank on top of the column. The nice thing about this is there's no gear train to deal with, it's just the threaded rod with a crank on the end. If there's a downside to this, it's that you have to reach all the way to the back. So depending on the size of the saw and how long your arms are, it may be difficult to reach back here and crank the thing. So I would recommend trying it before you buy it to make sure you can comfortably operate the height adjustment crank. At this point, don't be afraid if it's really hard to turn this crank, because until you clean this saw, chances are all the adjustments are going to be kind of crusty when you buy it. That's just the way it is buying antique tools. But as long as you can reach the thing comfortably, that's the key. The third most common height adjustment scheme is to have the crank mounted right about in the middle of the arm or towards the front of the arm. And usually, depending on the age, it'll either be a chain drive back to there or a little rubber timing belt with teeth on it back to there. The rubber timing belt ones usually are accompanied with a big plastic housing over the arm, which again, you want to inspect to see just what kind of saw are you buying at that point. But while you're looking under the plastic cover of that thing, you also want to check the condition of the little timing belt. Now the good news is, if you need to buy a new timing belt, you can buy a new timing belt. All radial arm saws have tables made up of multiple sections. Some of them have more sections than others, but they all have at least a couple sections with this fence in between. And depending on what you're doing with the radial arm saw, you might need to move the fence forward or backwards. And to do that, you have to unclamp these sections. This radial arm saw happens to have front-mounted knobs that work the clamps. If I turn the knob in the front, this clamp in the back loosens up. That's handy for making adjustments to a saw with a long table, because I'm not trying to reach back here. The other style of table clamp is simply a thumb screw attached to a little bracket back here that pushes on the backboard of the table. If we look right here, you can see here's one of the clamp knobs for the Rockwell saw. The DeWalt has the clamp in the back. If there's a benefit to this, it's that I don't have to reach into the back of the saw table to clamp and unclamp the boards. If there's a downside to it, it's that there's a knob that sticks out the front here, which limits how wide this table can be without notching around this knob. It also means that I can't use this front edge as a guide for cutting large pieces of wood with a straight edge clamp to it, because it'll hit these knobs. I could get around that by simply taking the knob off when I need to do that maneuver, but that kind of defeats the purpose of a handy knob in the front. If there's a downside to the clamp in the back, it's that I have to reach all the way to the back to clamp and unclamp the table, but it leaves this front edge clear to use as a straight edge when ripping large panels. Since we're working our way down to ground level, let's take a look at the two typical ways you're going to acquire a saw. They're either going to have a set of factory metal legs under them, or they're not going to have any legs and you're going to have to build some sort of little cabinet for it to sit on. If there's a benefit to the metal legs, it's that as soon as you unload that radial arm saw and go through an entire tune-up procedure to get it up to snuff, you are ready to start using it. You don't have to first build something to hold it. If there's a downside to it, it's that you've got all this open area down there that may or may not be wasted. If you have a sliding compound miter saw, that is an excellent place to keep your sliding compound miter saw. Other than that, it's kind of wasted space with those big legs in the way. If you don't have the legs, you can always build a cabinet with shelves or drawers under it to store all your radial arm saw accessories. Now, if you get a saw with metal legs, there's nothing to say you have to bolt the metal legs on, and in fact you can unbolt the legs and put the box part of the saw on a cabinet of your choice, and you get all the storage space. One thing you want to look at when buying a radial arm saw is how the table is attached to the saw. This is a place where the manufacturers started skimping out really as soon as they could. They started cheapening out this attachment point, so it's something to pay attention to. In this case, this one has a big cast iron piece that runs all the way back to the column out here with two big rows of bolt holes that the table bolts down to. Then on the outside, it has these two rails that it bolts to, one on either side, with jam nuts so you can adjust it up and down, because you want to be able to get this table to be level with the arm in all directions and have it stay that way. And multiple points of contact throughout the thing is a really good way to do that. Same with this 1030 round arm. You'll see it has one metal bar there, one metal bar near the center, and then if we turn our attention over here, one more metal bar that has multiple screws screwed down to it, and you can adjust those bars up and down so that way the table is perfectly coplanar with the arm. The nice thing about this, once again, is with the multiple points of attachment, this table can't sag because there's something right in the middle of it. The nice thing about that is that allows me to use just one piece of plywood instead of having to build a more complicated table with metal bars in it to try and get around the fact that some saws only attach the table here and out here, and then it sags in the middle. So just be aware, if you can get a saw that has multiple points of contact, the more the better. That's going to save you time and effort building the table. However, if you can only get one that has a mounting rail on either edge, that's okay too, because you can make a table that will support itself, but it's just how much effort do you want to put into that thing. If we take a look at this little one, it has a cast iron base all its own, and then it has 3 milled areas in it. So given the short span, lots of mounting locations, this table isn't warping at all. If there's a downside to this setup, or the Rockwell setup that has the big cast iron piece in the middle, these aren't adjustable up and down to get the work surface coplanar with the arm where the cast iron is. However, there's a couple ways around that. You can rely on the manufacturer making a good saw and having it be coplanar right at the cast iron level, and then you're all set. Or if there's some discrepancy in the casting, you can always shim it with little shims made out of paper or little wooden shims, whatever it takes, around the bolt holes in order to get it coplanar. So not a huge deal, just not quite as easy as the jam nuts that adjust the table up and down. Final thing is cross-cut and rip capacity. How much do you actually need? This is probably one of the most subjective things about this whole process, because it all depends on the size projects you're planning on doing. So I would recommend that you think about what projects would you like to build in your workshop and get a saw that fits that type of work. Be choosy about the saw, because if you get a good radial arm saw, you get it tuned up and you get used to using it, it's a tool that you're going to rely on for the rest of your woodworking career.